Inside your body, millions of cells are dividing, repairing, and replacing themselves. Some are doing this calmly and in order. Others are being checked, corrected, or quietly removed before they cause harm. These processes never stop, even when you feel perfectly fine. My name is Dr. Warren Hung. I'm a medical doctor, and this channel is We Care Health. I spend my days thinking about prevention and long-term outcomes, what shapes health over decades, not just what treats symptoms after they appear. In this video, I want to explain something that is often simplified too much, or explained the wrong way. We hear strong claims about food and cancer. Words like fight, kill, or cure get used casually. That language is misleading. Cancer is not a single enemy. It is a breakdown in how cells grow, how they use energy, how they respond to signals, and how the body keeps order. Food does not act like a drug. It does not hunt down cancer cells. But food does help set the internal conditions in which cells must live. To understand this, we need to step back and look at the body as a system. Cells do not decide what to do on their own. They respond to their environment. They listen to signals about energy availability, inflammation, repair needs, and immune control. When those signals are balanced, damaged cells are usually repaired or removed. When those signals stay disturbed for years, the rules change. This is where the idea of starving cancer is often misunderstood. Cancer cells still need energy. They still rely on the same basic fuels as normal cells, but they use them in inefficient and abnormal ways. The question is not whether a food can target cancer directly. The real question is whether certain foods can support the body systems that limit abnormal growth while allowing healthy cells to function normally. In this documentary, I will walk you through that question carefully. We will look at how cells use energy, how inflammation reshapes tissues, how the immune system monitors cell behavior, and how the body manages daily chemical stress. Only after we understand these systems will we talk about where specific foods fit and where they do not. But before any food makes sense, we need to understand how cells decide when to grow and when to stop. Every cell in your body needs energy to stay alive. Energy is what allows a cell to repair damage, make proteins, and divide when replacement is needed. The main fuel for this process is glucose, a simple sugar that comes from many of the foods we eat. Glucose itself is not dangerous. It is a basic fuel. The problem is not the fuel. The problem is how cells are told to use it. To manage this, the body relies on a hormone called insulin. Insulin is a chemical messenger released by the pancreas. Its job is simple. It tells cells that energy is available. When insulin rises, cells open their doors and take in glucose. When insulin falls, cells switch to maintenance mode and focus more on repair than growth. In healthy tissue, this system is tightly controlled. Cells respond to insulin when it is needed and ignore it when it is not. Growth happens only when the body gives clear permission. Once repair or replacement is done, the signal quiets down again. Cancer cells behave differently. Many cancer cells are less sensitive to the normal stop signals. They continue pulling in glucose even when it is not appropriate. They favor fast, inefficient energy production over slow, steady repair. This does not make them stronger. It makes them wasteful. But wasteful growth can still cause damage when it goes unchecked. This difference in energy use has been studied for over a century. It is often referred to as altered cellular metabolism. That sounds complex, but the idea is simple. Healthy cells switch between growth and maintenance. Cancer cells get stuck in growth mode. Now here is where confusion often starts. Lowering glucose in the blood does not automatically stop cancer. The body will always protect blood sugar within a narrow range because the brain depends on it. You cannot remove glucose from the system without harming normal tissues. What matters more is how often cells are exposed to strong growth signals and how long those signals stay active. When insulin levels stay high for long periods, cells receive repeated messages to grow and store energy instead of repair. Over years, this environment favors cells that ignore normal limits. This relationship between insulin signaling and abnormal growth has been examined in large population studies, including long-term cohorts like the Framingham Heart Study and NHANES, which show links between insulin-related metabolic dysfunction and higher cancer risk. These studies do not prove causation for any single food, but they do show that the internal energy environment matters. This is why food is relevant, but not in the way headlines suggest. Foods influence how quickly glucose enters the bloodstream, how much insulin is released, and how long that signal lasts. Some foods lead to sharp spikes and long recovery times. Others create slower, steadier energy availability. Over decades, these patterns shape the background conditions in which cells operate. At this level, food is not a weapon. It is a regulator. It nudges the system toward frequent growth signals or toward longer periods of repair and stability. Cancer cells cannot be selectively starved, but they are less adaptable to stable, low-noise environments than healthy cells are. Understanding this difference is essential before talking about specific foods. Without this foundation, claims sound magical or misleading. With it, the conversation becomes grounded and realistic. But energy signaling is only one part of the picture, and growth is strongly shaped by another quiet force in the body: long-term inflammation. Inflammation is not a disease, it is a normal biological response. When you cut your skin or catch an infection, inflammation brings blood, immune cells, and repair tools to the area. It creates heat, swelling, and redness, so healing can begin. Once the job is done, inflammation is supposed to turn itself off. Problems start when it does not. Chronic inflammation is low-level, persistent activation of these same repair signals. There may be no pain, no fever, no obvious warning signs. But inside tissues, immune cells keep releasing chemical messages that say, something is wrong, stay alert, keep repairing. Over months and years, this changes how cells behave. To understand why this matters, think about how cells normally divide. Healthy cell division is slow and controlled. The body checks the DNA, it checks the environment. It checks whether new cells are actually needed. Inflammation disrupts this balance. The signals meant for short-term healing start to resemble permanent instructions for growth. Inflammatory chemicals called cytokines tell nearby cells to divide faster, pull in more nutrients, and resist normal shutdown signals. These messages are useful after an injury. But when they persist, they create a background that favors survival of damaged or abnormal cells. This connection between chronic inflammation and cancer risk is not theoretical. It has been observed across many conditions. People with long-standing inflammatory diseases, such as inflammatory bowel disease or chronic hepatitis, have higher rates of certain cancers in the affected tissues. Clinical guidelines from organizations like the World Health Organization and European Society of Cardiology recognize chronic inflammation as a contributing factor in multiple non-communicable diseases, including cancer. It is important to be precise here. Inflammation does not cause cancer by itself. Most inflamed tissues do not become cancerous. But chronic inflammation increases the number of cell divisions, increases DNA stress, and reduces the margin for error. Over long periods, this raises the chance that a damaged cell escapes normal control. Now let's connect this back to food carefully. Food does not act like an anti-inflammatory drug. Eating one meal cannot shut down inflammation. But food patterns influence how often inflammatory pathways are activated. Some foods increase blood sugar spikes and oxidative stress, which stimulate inflammatory signaling. Others supply fiber, micronutrients, and plant compounds that reduce unnecessary immune activation in the gut and liver. Large population studies, including NHANES data, show associations between diets high in ultra-processed foods and markers of systemic inflammation, such as C-reactive protein. These are associations, not guarantees, but they help explain why certain dietary patterns repeatedly show links to higher disease risk over time. Another important point is location. Much of the body's chronic inflammation starts in the gut. The gut is not just a digestive tube. It is an immune organ. It contains a large portion of the immune system and is in constant contact with food particles and bacteria. When the gut lining is repeatedly irritated or overloaded, immune signaling increases not just locally, but throughout the body. This does not mean the gut is leaky in a dramatic sense. It means immune tolerance becomes strained. The body spends more time in alert mode. Cells receive more growth and survival signals than they should. Cancer cells benefit from this environment. They are better at hiding in noisy systems. They exploit confusion. Healthy cells depend on clear rules. So when we talk about foods that starve cancer, What we are really talking about is foods that help quiet unnecessary inflammatory signaling. Not elimination, not suppression, regulation. But even in a well-regulated environment, damaged cells still appear, and that brings us to the next system that decides their fate: immune surveillance. Every day, cells in your body make mistakes. DNA gets copied imperfectly. Proteins fold the wrong way. Most of the time, these errors are harmless and corrected quickly. When they are not, another system steps in before trouble begins. That system is immune surveillance. Immune surveillance is the process by which the immune system patrols tissues and identifies cells that no longer behave normally. Specialized immune cells, such as natural killer cells and cytotoxic T cells, scan for warning signals. These signals include abnormal surface proteins, stress markers, or signs that a cell is dividing when it should not. This is not an emergency response. It is quiet, routine housekeeping. When immune surveillance works well, abnormal cells are removed early. You never feel it, you never know it happened. This is one reason cancer does not develop every time a cell mutates. The immune system usually intervenes long before a tumor forms. Cancer becomes possible when this surveillance weakens or becomes confused. Some cancer cells learn to hide. They reduce the signals that would normally flag them as abnormal. Others create a local environment that suppresses immune activity. Chronic inflammation, which we discussed earlier, can exhaust immune cells over time. When immune cells are constantly activated, they become less precise and less effective. Age also plays a role. As people get older, immune surveillance becomes less efficient. This process is called immune senescence. It does not mean the immune system stops working. It means it responds more slowly and with less accuracy. This is one reason cancer risk rises with age, even in people who feel otherwise healthy. Now, where does food fit into this picture? Again, food does not boost the immune system in a dramatic or targeted way. The immune system does not need stimulation, it needs balance. Overstimulation leads to exhaustion. Undersupport leads to poor function. Immune cells are some of the most energy-demanding cells in the body. They need steady fuel, stable blood sugar, adequate protein, and sufficient micronutrients to function properly. When energy availability is chaotic, sharp spikes, followed by crashes, immune responses become less coordinated. Large observational studies, including data from UK Biobank, show that metabolic dysfunction and obesity are associated with impaired immune responses and higher cancer incidence. These associations help explain why immune surveillance fails more often in environments of chronic metabolic stress. They do not suggest that food replaces medical treatment, but they do clarify how long-term internal conditions matter. There is also the gut immune connection. A significant portion of immune cells interact directly with the gut lining. When the gut environment is stable, immune signaling stays proportionate. When the gut is repeatedly stressed, immune responses become exaggerated in some areas and blunted in others. This imbalance reduces the ability to clearly identify abnormal cells elsewhere in the body. Cancer cells thrive in confusion. They are less likely to survive in a system that is calm, well-supplied, and precise. So, when people talk about foods that support immunity, the accurate interpretation is narrower. Certain foods support the conditions that allow immune surveillance to function as intended. They do not act as immune weapons. They help maintain clarity. Yet, even with effective surveillance, cells are constantly exposed to chemical stress, and how the body manages that stress determines how much damage accumulates over time. Every time a cell produces energy, it creates waste. This waste is not trash in the usual sense, but chemically active byproducts. They are called reactive oxygen species. That term sounds technical, but the idea is simple. These are unstable molecules that can damage nearby structures if they are not controlled. This process is normal. It happens in every living cell. Breathing oxygen makes energy possible, and energy production always comes with this kind of chemical friction. The body expects it and is built to manage it. Problems arise when this balance is lost. Oxidative stress occurs when the production of these reactive molecules exceeds the body's ability to neutralize them. When that happens, proteins can lose their shape, cell membranes can weaken, and DNA can accumulate damage. Most of the time, repair systems fix this damage. But repeated stress increases the chance that errors slip through. The body relies on several layers of protection here. First, Cells contain internal enzymes that deactivate reactive molecules as soon as they appear. Second, the liver processes and removes chemical byproducts from the bloodstream. Third, dietary compounds, such as certain vitamins and plant-based molecules, support these internal systems by acting as helpers, not replacements. This is where the word antioxidant often gets misunderstood. Antioxidants are not shields that block all damage. Damage is unavoidable. Antioxidants help keep damage within manageable limits. Clinical research has shown that this balance matters. For example, large trials have demonstrated that high-dose antioxidant supplements do not reduce cancer risk and may even increase it in some populations. This is why guidelines from organizations like the World Health Organization caution against antioxidant supplementation for cancer prevention. Food works differently. Whole foods provide antioxidants in low doses, combined with fiber, minerals, and other compounds that influence how cells respond to stress. These compounds support the body's existing defense systems rather than overwhelming them. This distinction matters. Another key player here is the liver. The liver is the body's main detoxification organ. Detoxification does not mean removing vague toxins. It means converting fat-soluble chemicals into water-soluble forms so they can be safely excreted. This process depends on enzymes, adequate protein, and micronutrients. When the liver is overloaded by chronic inflammation, excess alcohol, or metabolic dysfunction, chemical stress increases throughout the body. Population data from NHANES show that markers of liver stress and metabolic syndrome often rise together. These states are also associated with higher rates of several cancers. Again, this does not mean liver stress causes cancer directly. It means the system that controls chemical balance is strained. Cancer cells are less tolerant of stable, low-stress environments. They depend on chaotic conditions where damage accumulates faster than repair. Healthy cells, by contrast, are better equipped to survive in balanced systems. This is why the phrase "starving cancer" is misleading here. Cancer is not deprived of oxygen or nutrients. It is deprived of disorder when the body's damage control systems function well. Foods that support detoxification and oxidative balance do not eliminate damage. They reduce background noise. They allow repair systems to keep up. Still, none of these systems act alone, and to understand how food fits realistically, we need to connect energy, inflammation, immunity, and damage control into one picture. Up to this point, we have looked at 4 systems separately: how cells use energy, how inflammation shapes their environment, how the immune system monitors behavior, and how the body manages daily chemical damage. In real life, these systems do not operate in isolation. They constantly influence one another. When energy signals are steady, inflammation is quieter. When inflammation is controlled, immune surveillance is clearer. When immune surveillance works well, damaged cells are removed early. When damage is limited, repair systems keep up. This is what long-term cellular stability looks like. Cancer does not appear because one thing goes wrong on one day. It develops when several control systems drift off course at the same time and stay there for years. Cells that should slow down keep receiving growth signals. Immune cells that should remove them miss the warning signs. Chemical stress accumulates faster than repair can correct it. This is why focusing only on symptoms misses the deeper picture. Symptom control matters. Treating pain, shrinking tumors, and slowing disease progression saves lives. Modern medicine does this better than ever, and these treatments are essential. But symptom control and cause regulation are not the same thing. One addresses what is already happening. The other shapes what is likely to happen next. Food belongs in the second category. Food does not replace treatment. It does not act like chemotherapy or surgery. Its influence is quieter and slower. Over time, food patterns affect insulin signaling, inflammatory tone, immune efficiency, and liver workload. These changes do not target cancer directly. They change the environment in which all cells operate. This is where the 5 foods discussed in this video belong. They are not cancer cures. They are not weapons. They are foods that repeatedly show up in dietary patterns associated with better metabolic control, lower chronic inflammation, more stable immune function, and reduced oxidative stress. These associations come from large population studies and long-term trials, such as NHANES, UK Biobank, and dietary intervention research like the DASH trials. These sources do not promise outcomes for individuals. They describe tendencies over time. Cancer cells struggle in systems that are calm, efficient, and well-regulated. Healthy cells are built for those conditions. When people hear the phrase starving cancer, a more accurate interpretation is this: reducing the signals and chaos that abnormal cells rely on while supporting the systems that keep normal cells resilient. That distinction matters. On this channel, the goal is not fear or false certainty. It is understanding. If you understand how your body maintains order, you can better understand why certain patterns increase risk and others reduce it without exaggeration or false hope. If this kind of explanation helps you see health more clearly, consider staying with We Care Health. This channel focuses on prevention, long-term outcomes, and explaining what is often missed when health is reduced to slogans.